Okay, number 2. A bank account grows over the course of a year, according to that formula. At the start of the year, the bank balance is £100. At the end of the year, it's 103. Find the constants. Okay, so you have the bank balance is A, E, K, T. At the start of the year, the balance is 100. So that means A is 100. Okay? And then you're told 1 year later, aren't you? You have 103. So you have 103 equals 100 EK. So 1.03 equals EK. K would equal ln 1.03, which is what exactly? What's the answer?
But teacher, I put the T 365.
That's fine. That will give you a...
So ln 1.03 divided by 365.
Oh, sorry. Yeah, it does say it's in days, doesn't it?
Yeah.
I'm sorry. And is my answer not in days? Did I do the answer in years or something?
Yeah.
What? Is that what it is? Okay. Oh, Dasha. Okay. Come on. So what is log 1.03?
No, 1.03 is 0.0295.
And if, sorry, so if I was using days, where that's 365,
Yeah.
and that's 365, so then I need to divide by 365 my answer.
Yes.
What do I get?
8.0
Oh, okay, so it is right. 8.1
times 10 to the power -5.
minus 5. Okay. Okay, so it's right as long as you use days. So lastly is you want the bank balance after a year and a half. So that's 100 E 8.1 times 10 to the minus 5, and then whatever a year and a half is in days. 547 days, is it?
Yep.
Okay, and then this is 104.53. Who was asking me for that one? Is it okay?
Yeah.
Was it just the days? Yeah. You did what I did and used the years, was it?
Yeah.
Yeah. It's okay, Ishpreet. Geniuses think alike, you know, so it's fine. Okay, we'll do number 3 next, yeah?
Yeah.
Yeah. Can I scroll? No, I see people writing. Are you taught about your costume? Oh, good. Scary or fun? You're going scary? Okay.
Fun for me.
Fun for you, okay. Okay, can I scroll down now? Yeah. A town consumes 12 megawatts a day at the start of 2013 and then consumes 13 megawatts a day at the end of 2013. Model the energy consumption to be exponential, write down the formula. So what you're saying is, there you are at the beginning, and then 1 year later, you went from having, what was it, 12 megawatts, and then a year later the town increased to 13 megawatts a day. And you're assuming it's going to be exponential, so the formula, what letter would I call this?
E.
I call it E, yeah, E and T. So energy will equal A, E, B, T. Now I think, I hope you can all see straight away what the big A is. What's the big A? 12, because it starts at 12. Okay. So E equals 12 EBT, and I think we know the story. To get the B, we have to use the second point here. So that is 13 equals 12EB. So divide by 12, and then just get the log of 13 over 12. And what's that, please? Small enough number, isn't it?
0.214.
Uh-oh.
I
Is
did
it-
it a different way, teacher.
Now just so you know, in this question, I didn't say to use days or years, did I? I just said, what did I say about, I just said the year. Yeah. So, in the exam, it means students who use years to measure time will get a different answer than students who use days. And both answers are fine. But in my experience, in the exam, they usually tell you which unit of time to use, days or years. I'm using years. Okay. Right. You said you did it a different way.
I did it days.
Ah, yeah, so that's fine. So you'll get a smaller value for B. Yeah. Okay. So we have our first formula. The energy is A E 0.214 T. That's our first answer. Okay. Can we do our next one? So the next one is, they say, or I say, imagine that the formula, instead of being exponential, is linear. So that is, your picture in the graph is like this, going through the 2 points. And we want to find the formula now. So we all know the formula for a straight line, y equals mx plus c. So in this case it'd be E equals mt plus c. Yeah. And in fact we can see what the c is. What's the c here? It's 12, isn't it? And then how can I get the m? Well, by using the formula. M equals y2 minus y1 over x2 minus x1, which equals 1. So that means E equals 12 plus T. Now the last part is, what would be the difference in the two models if you were to predict for the next year? So you'll get two different answers if you were to predict for the next year out here, sorry, year 2. Which answer would be bigger? The exponential or the linear? Well, have a look at the graph. Yeah, be the exponential. You see this one here will be higher. So let's put in the value of 2 into each of these and see what we get. Well, this one here is this one here is obvious. It's 14 megawatts a day. Can someone pop 2 into that, please, and tell me what you get? So this is E using the exponential formula. So 12e power 0.428, whatever that is, 12e power 0.428. What's that, please? 18.41? Yeah. So, are you sure? Seems kind of big. It is? Okay.
Where's the 0.428 from?
Oh, I put T as 2. Isn't it 428? Because I'm putting in the value T as 2. We started off in 2013, isn't it? Yes. Is 18.41? Huh. That means my answer is wrong, or I did something wrong. Unless I'm misreading something. What would the difference be between the two models as used to predict the energy demands for the end of 2014? What's that a difference of 4.41? Yeah, if you were to minus these two? 6. 18.41 minus 14 is 4.41, isn't it? Oh, but maybe it's because, what happens if you divide that by 365, please? What do you get? Oh no, that's not it. Okay, this is my this is my answer, but it's totally different to the answer in the book, and this seems wrong. My 18 just seems too big. Can we double check this value here? Can we type in log 13 over 12? Oh, it's not 0.214. Oh, well that will explain that. Who gave me 0.214? Alright, what is it? What is it? Should be 0.08. Okay, so that's totally different. So we just need to change this guy here to 0.08, which means we just need to change this guy here to 0.16. Okay, so now what do we get? That seems better. 14.08. Excellent. Okay, and so the difference between the two matches up with my book now, which is 0.08. Okay. Now I'm going to ask you a question. It's a question that I've seen in the exam before relating to this question. It's like a part 4 of the question for 1 mark. You know, finish off the question with a 1 mark part. And the question was something like, it'd be something along the lines of, which of the 2 formulas do you think is more realistic and why? Something like that. So, what do you think, guys? Are we going, which would be a more accurate, more realistic formula for modelling the power consumption of the town? And you can use some biology knowledge here if you can think of how this is similar to something in biology. So is it going to be exponential or is it going to be linear? Linear, we're saying? And the reason why? It's easier. Ah, no. Is that a biology reason? You do it because it's easy to read? No. It's something different. What would you say? Yeah, but my question is, which is more realistic? Which will more accurately represent real life?
The linear.
You think so, yeah? I would have said the exponential. Yeah? Why? Why? Yeah, it's population. So you know from biology that things tend to grow exponentially, or you don't know this yet? No, okay, well you know it now. Things tend to grow exponentially, but not forever. What happens eventually? It stabilizes and then it's linear and then probably constant. Has Colin not done that graph with you yet, like the bacteria or the protein or whatever, where at the beginning its growth is exponential? No? Okay. And then, yeah. Are you sure you haven't done this with him?
With enzymes, yeah.
You did it with him?
But enzymes are so rich.
Oh, it doesn't matter if it's an enzyme, a bacteria or whatever. The graph is exponential at the beginning, yes? Then linear, and then it levels out at the top. Yeah. So in real life, I would say probably want to use exponential first, then linear, and then the town sort of stabilizes then. Yeah. Another question that they could have asked, which I've seen before, is they might say something like, what is a disadvantage of using the exponential? Or what is unrealistic about using the exponential? So the answer for that is, it's not going to be exponential forever. Again, it eventually levels off. So, you know, you couldn't use this formula to predict what will happen in 100 years. The town might not even be there in 100 years, you know. So that's the problem with exponential. It's only really good for a short time in predictions, okay? Right, what are we doing next, did you say? 4, is it? Yeah? Okay, number 4. Anne invests in a financial product that yields 12% APR converted monthly. Does anyone know that? If you don't know what that means, it's in brackets. This means the bank pays out 1% interest per month. How long until she doubles her money? Now, the time we'll use is number of months. That'll be, that's not how you spell months. Oh my goodness, I'm so sick. Number of months. And the formula for the bank balance will be A, which is how much she has at the beginning. And the way you increase by 1%, what do you multiply by? Not quite this. No. 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 1.01. And then you do that each and every month. Yeah? Now, if she starts off with A, we want the time it takes for her to achieve 2A. Like that. Which means we want 2 equal to 1.01 T. Yeah? So what we could do, in fact, if you have the log button on your calculator, you can just type in log base 1.01 of 2 and we're done. I think it's roughly 69 or 70, something like that. 70 is what I have here. We have to round up because we want enough time to make sure she at least doubles her money.
So if we get 69.3, can we round it off to 70?
Yeah, I think you have to. You have to, yeah. Well, I don't actually really say it in the question. No, it would only make sense here. If the bank pays interest every month, then if you say the answer is 69.3, then you're really only saying the answer is 69 because the bank won't pay interest again until you get to 70. You need to at least get to 70 to double it.
Actually, we don't have the log button.
If you don't have the log button, then why don't you? And what you could do is this. You can put ln on both sides. And then bring the t down in front. Like this. And then divide by log 2 over log 1.01. That's one way to do it. Also, Priscilla, the other thing you can do here, look, you don't have this on the calculator is what you're saying. You can use the change of base formula. So you change it to base E. Which is actually the same thing as that. Doing it this way. There's a couple of things you can do. Okay, you got that written down? Yeah.
I got 69.6. So I make it 70.
Yeah. 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 Okay. Is there any other questions from other lessons? I mean, or this one? I don't know how many you've
I
done.
have a question on the
Yeah.
exponential equations.
Good. Yeah.
In 5a.
Oh yeah, 5A. Yeah. Let's have a look at that. Were you asking me this one in class?
Yeah.
You were asking me this one in class. Y equals EX. Y equals E minus X. Okay, so we substitute. Is this part okay, Matar? Yeah, that's okay. And then, tell me, what did you do next, or what did you try to do?
I just erased everything.
What?
I erased everything.
You gave up and deleted your work. Okay. Dasha, what did you try to do?
Like, just saying, give up, but.
Well, what do you think we could do next? I think we should move, yeah.
And after we have playground in schools.
Yeah, well, what could we do next?
We can subtract E1 over E4,
Okay, if you want to do that, yeah.
Always try what equals
Like this. If you want, yeah. And then if you do that, what could you do next?
we can multiply for x.
We could multiply by EX, yeah.
And after it's like multiply for y prime.
It's kind of a quadratic, isn't it?
Yeah.
But it's a little bit tricky of a quadratic. But it is like a quadratic. It's like EX squared minus 1 equals 0.
This was my last.
Yeah? You got this far? Okay. Who knows what to do next then? Log is possible, yeah. But I would take the 1 to the other side. So, actually, I think there's probably a couple of things you could do here. In fact, I can think of 3 things you can do here. Yeah. The first thing is, if you spot it, you can factorize it, because this is EX squared minus 1 squared. And you have a formula for A squared minus B squared. Does anyone remember this from school? A squared minus B squared?
A minus 1.
Yeah.
A plus 1.
No, nearly, not quite. You're thinking of A squared minus... Oh, well, in this case, yeah. A squared minus B squared is A minus B, A plus B. In this case, it's A squared minus 1, which is A minus 1, A plus 1, which is what you were saying. So that's EX minus 1 times EX plus 1 equals 0. That means EX equals 1 or minus 1, but why don't we take the minus 1? You can't have minus here. And then we get x equals log 1, which equals 0. Another method is on the second to last step, you could have taken the 1 to the right, and then you could have said 2x equals log 1, x equals log 1 over 2, which equals 0. Yeah. And then I had another idea in my head, which I forgot now. What was I thinking a second ago? Oh yeah, at this first step, you could have said x equals minus x. So then you would say x plus x equals 0, 2x equals 0, x equals 0. You could have done that at that step. So you had 3 ways to finish this off. And which lesson?
This one, exponential equation.
Yeah. Can I scroll down? Much higher?
Yep.
Yeah? I'm going to have a look at 7b now. Fx equals 5 plus 6e minus 3x and x is more than or equal to 0. So if f was 0, you would get 5 plus 6e0, which is 11. What happens if f goes to infinity? You would get 5 plus 6e minus infinity. What would that be? What's that? Come on. 5. So what's happening is you're starting off at 11 and you're lowering to 5. You do actually achieve 11 at the beginning, but you don't really make it to 5. So the answer is 5 to 11, like that. Why did I put the answers like that? Oh yeah, 5 to 11. Oh, Stephen, that's wrong. The 5 you don't actually get. That shouldn't be equals. No, I'm sorry. 5 you do get. 5 you do get. No, what am I saying? The 5 you don't get, I was right the first time. The 5 you don't get because you can't quite reach it, and the 11 you do get. There we go. Yeah, that's the mistake in the answer. Oh yeah, there's 2 mistakes I need to fix. There was that one, and then there was one from a previous lesson. Can I borrow a pen for a second, just so I can remember to fix this? Yeah.
Shouldn't the line be going upwards instead of downwards?
It starts off at 11 at f0 and it gets to 5 at infinity, and it's a negative exponential, so I think it should be going down. I think I'm okay with that. Some people might even have a graphing calculator. Does anyone have one? No. Does somebody in the other group have one? I thought I saw somebody with it. Oh no, it's an engineer. That's who I saw with it. Oh my goodness. Okay. What do we need to see next?
Question 9.
On which page?
Practical problem.
Practical problems again? They're so boring. Alright. Where the heck is it gone? Yeah.
Why is the answer in like 7B, you give it in bracket form, but in the book it's like
Which page am I looking at?
page 53.
53. Yeah, which question?
7B, the answer is like in like
7B.
The one we
53.
just did.
Oh yeah.
the answer is in a different form.
The answer is in what form?
No, the answer that has like the equal, the
Huh?
lesser and
Oh yeah, that's my mistake. I said it should be written like this in the book. Sorry.
any
It's-
question.
I think it looks like, yeah, I should have written 5 less than 5 plus 6e minus 3x less than or equal to 11. So that's probably the case with C as well, I think. 3. No, C looks okay. D looks okay. Actually, yeah, it was just it was just in B I made that mistake.
So in the exam, do you write in the bracket form or the downward?
What do you think?
Most of them.
Yes,
They both mean the same thing.
they both mean the same thing, yeah. Although, can anyone see what use of English or what part of the sentence is making me write it like this in the answer? Like this is, Ishpreet, this answer in the answer page is a little bit more proper for how I asked the question. But I mean, this is fine. But can anyone see why I might have done this? Like what? Yeah, but not just that. It's because of the verb at the start. Place boundaries. So visually it's almost like you're saying, here's your thing, and you're placing two boundaries on either side of it, and you're saying it's in between it, you know. How might I have phrased the question if I wanted it like this? What could I have said? Well, yeah, I could say expressed in the form of a set, but something more interesting, more exciting. What could I have said? Yeah?
Intervals.
Huh?
Something about intervals.
Yeah, I could say something about what's the interval of values. That would be fine. Anything else? What's the range of values? Yeah? What else could I say? What's the set of values? What are the possible values? Whereas this one here, do you get what I'm saying with the verb place? It's like you're almost physically putting these two numbers around your answer, and you're saying it's in between these two numbers. So, are there any other ways I could have said that? Place boundaries, put boundaries, you know. I could say, you know, what are the no, I think really I can only say place boundaries or put boundaries. Oh, boundary can also be used as a verb. So, if you were using boundary as a verb, what would you say? Yeah, come on. You all study English, don't you? If you use boundary as a verb, what would you say?
Boundarize.
Boundarize. I love it. It's not this though. It's not this, but I do like it. Anything else? I wish it was this, but it's not this. What is it? Ah, come on, guys. Somebody knows this, I'm sure. Bound, yeah. So you could say bound the function. You know, that's the verb for boundary is bound, isn't it?
Yes.
Right?
Yes.
Yeah. I don't know if I'm telling you something new or you knew this already. Did you know this already?
Yes.
Yeah. Okay. So. Well, okay. Right. Write this one down.
Teacher, so are you scary of fun?
I don't see. I haven't even decided that yet. Usually fun though. You have your costume, Vanessa? Yeah, you have an idea? Okay. Yeah.
What's the difference between the log here and here?
Ah,
In school, I only used log when
who remembers what I said on the calculator? The difference between LOG and LN is?
The math and for punishment.
Yeah. So what's the maths like? What does LOG and LN mean?
LN is for log base E.
What's this one?
The basis.
Base
Yeah, and this one?
is
E. E.
Yeah.
So we never use the base name?
Very rarely. Very, very rarely. I would suspect chemistry and biology is where you would use this base, especially chemistry with the pH calculations. I think Lorraine will do this with you at some point. What are you doing at the moment in chemistry? Huh? You haven't done pH yet. Is that going to be done in the first semester? I think semester 2 is organic chemistry or something, isn't it? Yeah. So it probably will be. You've talked about ions, haven't you?
Yeah.
And positive ions, and
Yeah.
so it should be around about this part, shouldn't it? I think Lorraine gives you the formula for it. I think you'd have to check your notebook. Okay, what else do we need to see? Yeah, which one? 7? Yeah. We did 6 in class.
Yep.
This, I'll give you a pro teacher tip. When students ask you to do something you already did, it means they probably weren't listening the first time. That's pro teacher tip. So we won't do 6, we'll do 7 instead. Yep.
Wait, who asked us?
No, don't embarrass them. Right. We'll ask for 7.
Can we answer in like 9?
9?
So it's the same as 8?
It is.
Yeah, but it's kind of different.
I don't know. I don't like the look of it. I think I put too much chemistry in it.
Yeah.
It's putting me off it. I don't like the look of it at all. 9 and 10 are a bit ridiculous, if I'm honest. As for a maths problem, there's too much chemistry in it. But no. We'll get 7 done, and
But 7 is like...
what's wrong with 7? No, 7's a bit tricky. It's a bit tricky. A teacher is playing a warm-up game with students. He's thinking of a word in the dictionary, and the student wins when they have guessed what word he is thinking of. If they guess wrongly, the teacher will say if the word they guess comes before or after his word. For example, if he's thinking of cat, and the student says bat, he will say no, but my word comes after bat in the dictionary. How many guesses will the students need to make before they guess the right one? Assume the teacher knows 16,000 words. Okay, so we'll have a go of this. We'll start with you. I am thinking of a word. Okay, guess a word. Yeah, I'd be amazed if you get on the first go. So, what word am I thinking of?
Hat.
No, but my word comes before this in the dictionary. Go.
That.
Wait, before he just said
Huh?
he said,
It doesn't have to be. He said cat.
it doesn't have to be in order, like,
No, I'm thinking of a word.
Wait, what word did you say? Cat.
No, he said head.
Hat.
I heard hat.
Oh, hat.
Yeah.
Okay, well, it still doesn't matter. My word is before this in the dictionary. Okay? Right, sorry. So, okay. And then you said,
Can I do this but and
yeah, fine, you said bat.
that but
Okay, so my word comes after bat in the dictionary. So far we know it's before head and after bat. Go.
Cat?
It is after cat.
Elevator.
It is before elevator.
Dad.
It is after dad.
Dad.
It is after die. Oh, you're picking hard words to spell. It is before dragon. Okay.
Danger.
After danger. After dinosaur.
Dungeon.
Before dungeon. Yes?
Discriminant.
Discriminant. That does seem like a word I would think of, doesn't it? After discriminant.
Displacement.
Okay, you're going to take too long because you're thinking of fancy words. I was thinking of dog.
Oh.
Okay. Anyways, you get the idea of how the game works. So the question then is, how many turns will it take? So what do you think? What is the most turns it will take? That's what we're trying to calculate. Let's have a look at how we imagine this game goes. So it starts off with a possible list of 16,000 words, right? 16,000 words possible. Then if you make a smart first guess, what would be a smart first guess? A middle one, yeah. Like what letter is that? That's M. Yeah. If you make a smart guess, then how many words could you eliminate on your first guess? Half of them. So after one guess, you could reduce your possible pool to 8,000.
After you make another half.
And then another guess, if you choose a smart guess, you could reduce it by half again. And a half again. So what's happening is the number in the pool, we'll say pool, is going to be 16,000 times 1 over 2 power guess for the number of guesses you make. Okay? What do we want this number to be in the end? 1. We want to narrow it down so there's only one possible word left. So that's 1 equals 16,000. 0.5 guess. So 1 over 16,000 equals 0.5 guess. You can use log. You can say the guess is log base 0.5 1 over 16,000. Does your calculator do that? What do we get here? 13.96. Yeah, which is 14.
So can we use trial and error?
For solving?
If in the exam like we forget to do all this, can we just use trial and error?
Oh, maybe. But try not to forget. Yeah? So 14 guesses. Because you can't make 13.96 guesses. Okay. Okay. So if it takes you longer than 14 guesses, it means you haven't picked the best words each time. Because in the worst case scenario, it could take you 16,000 guesses. Because you would start off by saying, is it aardvark? No. Is it apple? No. And then you finish with, is it xylophone or zebra or something, you know? I don't even know what the last word would be. Not zebra. Zinc, well. Zoo maybe? Might be something after zoo. Yes, I don't know. I think the first word, actually the first word is A. They always start off with A, I think, just by itself. I don't know what the last word is. So, yeah, maybe.
Ziziva.
Oh, go on. How do you spell that?
Z-Y-Z-Z-Y-V-A.
Z-Y, Z-Z-Y. V?
V-A.
V-A?
Yeah.
What the heck does that mean? What's the definition?
Is a genus of tropical American rose often found in associated with palms.
So it's a plant, is it?
Yeah.
Yeah.
It is scientific. Oh yeah. It is.
Z-Y, Z-Z-Y.
I need to find picture.
Okay. It makes me feel like we should invent a word that just starts with ZZ so we can have it at the back. You know, like Z. Ah, wow. I discovered ZZY, ZZY. You know, the first Z is silent. Okay.
Oh, this is an insect.
It's an insect, is it?
Yeah. Look at this one.
Right. Okay.
Teacher, actually number 6, I had a question.
Oh, what's wrong with it? Yeah.
Because yesterday in the example,
Yeah.
I got A is 100, but then I
Yeah.
did it again and I got A is 1 as well. Is it the same?
Yeah, it depends if you're using percentages or decimals. So both are fine. It's like our example with the time,
Days.
if you're using days or years.
Okay.
As long as you're consistent, it should be fine. Okay, we don't have class tomorrow, right? Or later today. So, do you have your timetable for the exams?
Yeah.
Yep.
Yeah? What day is the maths on? It's early in the week, isn't it? Tuesday?
Tuesday, 9 o'clock in the morning.
Tuesday, double class. Yeah? I'll make the exam a little tough. I'll tell you now. Be a little tough. And I feel like practical problems will feature strongly on it.
No.
Yeah. Yeah. Just, you know, keep you on your toes. Okay?
Is
Yeah.
it until law?
Everything. Everything we've done so far. So up until practical problems of today. Yeah. Yep. So you've been warned, okay? You have the exam as a double exam, and it'll feature practical problems. Okay? I mean, the exam wouldn't be interesting if I gave you questions you could easily do. Agreed? Yeah, agreed. Okay, right. I'll see you after the break. No, actually, I'll see you tomorrow, won't I? I'll see your scary or fun costumes tomorrow. All right. Are you in this